Hi, welcome to the statics tutorials. So in this video, we're going to use the method that we developed in the last three videos now to add some vectors together. So our problem statement is to find the resultant. We have a hook here, and then the hook has F1, 705 newtons acting at 50 degrees to the x-axis, and it has F2, which is 795 newtons with a 3, 4, 5 triangle drawn on it to show its direction. And then we have F3, which goes only in the negative x direction and has a magnitude of 821 newtons. So let's look at how to break these three vectors up into components, and then we'll add the components up. So for force vector 1, we can get its x component. It would be equal to its magnitude times cosine of 50 degrees. We're using cosine because the angle is measured to the x-axis. We get the 453 newtons. It's going in the positive x direction. Imagine that F1x vector going here along toward the right in the positive x direction. So it's positive. For F1y, we have 705 newtons sine of 50 degrees. And you'll notice with these problems, if you use cosine for x, you'll almost always use sine for y and vice versa, because your triangle is always going to be with the vector being the hypotenuse. So we'll get, when we plug in our numbers, we'll get 540 newtons for F1y. And then looking at our directions, our y component would have to go in this direction to be able to add up to this vector. This vector points in this direction, so it's a positive x, positive y to get back to that vector. So that's why we have a positive number here. Looking at our second vector, F2, we have our 3, 4, 5 right triangle. Remember that we have two ways of looking at it. One way is to think about this angle and think about cosine of that angle. That would be the 3/5 ratio then for x. Or the other way of thinking about it is to say, hey, the x component is parallel to this 3 side, so I'm going to put the 3 on top in my fraction, and then the hypotenuse always goes in the denominator down below in my fraction. So it'd be 795 times 3/5, and we have to do our direction, and it looks like we're going in the negative x direction with this vector, so that one gets a negative sign. And then for F2y, since we use the 3 side here, we have to use the 4 side for our y component. But thinking through the same analysis, if this is our angle theta, now we're looking at the opposite side, 4 divided by the hypotenuse 5, or we're looking at the side that's parallel to the y, which is the 4, divided by the hypotenuse, which is the 5. So either way, it's our 795 times 4/5 here. We get our 636 newtons. And then looking at the direction, looks like we're going in the positive y direction, so that one's got to be a positive component. Now looking at F3, we have F3 and the whole thing goes in the x direction. So the x component is equal to the whole thing, and we just have to assign a positive or negative sign to it. So we're starting here at the origin, we're going in this negative x direction, so we assign a negative sign to it, so it's just negative 821, and that means the y component for F3 has got to be completely 0. Now to get our resultant, we just add up the x components separately and the y component separately. So let's look at the x first. So this means a summation sign, this means add everything up. This fx is just a stand-in for each of the x components. So this includes the 453 newtons, the negative 477 newtons, and the negative 821 newtons. So you can see those are in here with their positive and negative signs. And that gives us a negative 845 newtons for our x component. And then for our y component, we're going to add up all the y components. So sum of all of the y components, so this would be 540 newtons plus 636 newtons plus 0 newtons. So that gets us 1176 newtons. And then we could write this a bunch of different ways. This problem didn't specify how it wanted the resultant written. If the problem statement says write the resultant as a Cartesian vector, remember that with a Cartesian vector you're using the i's and the j's, and so the i's are the x's. So you take whatever you got for the x, include the sign, plug it in here in front of the I. You take whatever you got for the y's and plug it in here, including its sign in front of the j. I went ahead and converted over to kilonewtons because this number is slightly larger than 1,000. So if I convert to kilonewtons, that puts both numbers in that range of 0.1 to 1,000. So we have negative 0.845i plus 1.18j. And then we typically put the brackets on both sides of the Cartesian vector and then put the unit just once here at the very end of the Cartesian notation. If you want the magnitude and direction information, we can also solve for that. So the magnitude of FR is equal to the total x component squared plus the total y component squared. Add them together, take a square root. We get 1.45 kilonewtons, and I've divided that by 1,000 to convert it to kilonewtons, again because it's a number bigger than 1,000 if we left it in newtons. And then we can calculate our angle theta. Our angle theta that we calculate is always going to be the angle to the closest x-axis. So in this case, it's going to be the angle to the negative x-axis, but this would be the inverse tangent of our y divided by the x component. When you're doing your theta, always do your absolute value too of that ratio. So it's going to be 1176 divided by 845. Don't include the negative sign in there. You want a positive number when you take the inverse tangent. That gives you that this angle here is 54.3. Now be careful when you're answering problems out of the text or out of the instructional materials because they may ask for a lot of different angles. So if they had asked us for the angle measured counterclockwise from the x-axis, they would be asking us for that angle. To calculate that angle, we'd need to say, hey, we calculated the angle to the negative x-axis, so this angle would be 180 degrees minus the 54.3 degrees. And that would be the angle that they're asking you for. If they ask you for an angle clockwise from the positive x-axis, that would be this angle over here, and then you'd have to do 180 degrees plus 54.3 degrees. So if you find that you're working the problems out of the book and you're getting the magnitude correct, but you're not getting the angle correct, look and just double check and make for sure that you're reporting the angle that they're asking you for in the problem statement. Thanks for watching.